The video will be up for you, okay? And the homework is at the end of the page, so keep you going there. All right, so this is 12.6, more quadratic equations. More quadratic equations. We have now learned the three main ways of solving quadratics. And that is by factoring, specifically set it equal to 0, factor it, set the factors equal to 0 and solve, so one factoring. 2, by roots, which is technically isolate the squared variable, take the square root of both sides. Don't forget the plus minus. The third way, basically, is the quadratic equation, which was last night, which again is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So we've dealt with the three ways that you're going to solve quadratics. Now today we want to look at some of the aspects of those three ways. All right, so number one, the type of solution for a quadratic equation can be determined by the value of the term here is the discriminant. Discriminant. D-I-S-C-R-I-M-I-N-A-T-E, the discriminant. You say, what is the discriminant? It's the radicand of the quadratic equation. The b squared minus 4ac is called the discriminant. I'm not a big discriminant fan, but here's what it's for. The discriminant will tell you what type of solution you have. And there are three possibilities on the solutions. And so by knowing the value of the discriminant, you'll know which of the three types of solutions you have. In my estimation, to figure out the value of b squared minus 4ac, you're almost done with the quadratic equation. Why not just do the negative b, the plus or minus, and divide by the 2a and get the actual value yourself, and you'll know what type of solution you have. So to me, I don't see a lot of value in figuring out the discriminant. You might as well just go the little bit more and get the actual values, and you'll know what type of value you have because you solved it. But people think that you should know what a discriminant is, so I have to teach you what a discriminant is. Now, by the way, we have to discriminate. We are discriminating. Now, to you guys in 2016, you think I just said a bad thing. All discrimination is bad. That's because you've been programmed. In our country today, it's been programmed to think that any discrimination is bad. Is it wrong to discriminate on basis of a person's color? Absolutely, no doubt about it. But the concept of discrimination itself is how human beings operate. For example, I'll give you an example. Let's suppose I'm walking down the street. It's late at night. I'm by myself. And I've got to get to my car. And my car is down the block quite a bit. And I'm walking down the street. And I notice up a ways people in front on the sidewalk that I got to go past. And I see it's a bunch of bikers. And they're loud and carrying on. Do you think I'm going to discriminate? You bet your life I'm going to discriminate. I'm going to make one of two choices. I'm either going to cross the street before I get to them and walk on the other side, or I'm going to actually make a right-hand turn and go a different way to get to my car and not pass them at all. Why? Because there's danger in going by a bunch of bikers that are loud and carrying on at night, and I'm by myself. I'm not stupid. In math, we discriminate. And in life, again, there are situations where discrimination is a basic skill of human beings. Our country has gone crazy on it, and now, we call it all kinds of different things. Again, within a race that is stupid, you cannot lump everybody into a category based upon their race or whatever. That's stupid. People are people, and they're individuals, obviously. But the idea of to discriminate is actually something that does take place at times, but you guys have been programmed that it's a bad thing. All right, enough of the philosophizing. But again, what is the discriminant? It's the b squared minus 4ac of the quadratic equation, and it will tell us a few things. All right, so the discriminant is the radicand, as I just said, of the quadratic equation. So here's the three possibilities. So you're supposed to find the value of just b squared minus 4ac. No square root symbol, no nothing. Just the value of b squared minus 4ac right there. Okay? You just figure out the value of b squared minus 4ac. And you got a couple possibilities. I'm going to use my green here. The first one is if the value is greater than 0. Interpretation. That means it's positive. Okay? Positive numbers are greater than 0. So you get a positive, here's the thought, a positive radicand. A positive radicand. That means you have two real number solutions. Two real number solutions. But there's two parts to the two real number solutions, because there's two possibilities when the radicand is positive. What if the radicand ended up to be a 16? Can we evenly take the square root of 16? We can. And therefore, then, the radical is going to be gone. And the two solutions we're going to get are not only going to be real numbers, more specifically, they're going to be rational numbers. So you get two rational number solutions. And if you remember, rational numbers, anything that can be a fraction. Okay? If the radicand, the b squared minus 4ac, the discriminant, is not a perfect square, like 17, can we evenly take the square root of 17? No. So we're going to leave the square root of 17, right, in our answer. And square roots are what kind of real numbers? They're not rational, they're irrational. So you had two irrational number solutions. Okay, so positive radicand, two real number solutions. If they want you to be specific, you have to figure out whether it's two rationals, perfect square, or if it's two irrational. And by the way, the perfect squares are what? Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5, etc., right? Square root of 36 is 6. 49 is 7. 64 is 8, etc., etc. Okay, so here we got a couple examples. So just go ahead and figure out the value of the discriminant on each of these. If you're just doing b squared minus 4ac, you guys do it there while I do it here. I left things color-coded for you. So we're just doing the value of b squared minus 4ac. If you need to look, but hopefully you can do it without looking. So just do them both, and then we'll figure out what type of solution. I'm going to skip some steps for time's sake. Should have gotten 25 for the first one, and let's see, 16 and 12, 28 for the second one. Anybody agree? 28 for the first, b squared minus 4ac. And for the second one, b squared minus 4ac is 28. So if we were going to be specific, we did get values that are positive. So we know we have two real number solutions. But specifically, this left one is two rational number solutions. And because we got a 28 on the second one, the discriminant tells us we get what? Say it. We get what? How many? 2 irrational number solutions. Again, I'm not a big discriminant fan for the very reason of we did all that work. We're almost done with the quadratic equation. Believe me, if you finish the one on the left, you'd see you have 2 rational number solutions. Which, by the way, integers are also rational numbers because they can be a fraction. Can a 7 be a fraction? Yes, 7 over 1. 14 over 2. So, but anyhow. All right, that's the first scenario. The second scenario. What if the discriminant equals 0? The first situation was the radicand was greater than 0. Second scenario, what if the radicand equals 0? Well, technically you get 2 solutions, but they're both what? The same number. So we say 1 rational number solution. 1 rational number solution. So again, technically 2 solutions. I should say the 2 solutions are the same value. So that's why some say 1. Because remember, every quadratic has 2 real and or imaginary number solutions. Okay, let me go higher for you guys, so let me get rid of my shade. Okay, so go ahead and figure out the discriminant for this second example. Again, you're doing b squared minus 4 times a times c. And lo and behold, what did you get? 0. So what would you say the solutions are? 1 rational number. Right. B squared minus 4ac gives you 0. Therefore, solutions, 1 rational. Hey, let me just show you here back on the quadratic equation, right? So watch. When the radicand is a 0, this whole thing is gone, right? Therefore, does the plus minus do anything? No. And that's why you only end up with 1 solution. That's going to be a fraction, a rational number, right? That's what's going on. Daydreamers, good for you. I hope you daydreamed well. Hope you enjoyed your daydream, but you really didn't hear a word of what I just said. And hence, sometimes when you struggle not knowing what to do, I'm telling you that is the reason. You do have to focus in the class. All right, the third scenario. So we could have values that are greater than 0, positive values. We could get a value of 0 for the discriminant, or we could have values that are less than 0, right? It's the other possibility, which, by the way, are negative numbers. Negative numbers. All right, I have to give this a couple different ways because it depends on who you're talking to, how they want you to say this. All right? So we could say 2 complex number solutions. I'm going to put a parentheses underneath. Some say imaginary. Imaginary numbers are complex numbers. So it depends on who you're talking to, which way they want it. And I'm going to give it to you both ways, just in case your book wants you to say imaginary number or whether it wants you to say complex. They're one and the same. All imaginary numbers are complex numbers. Okay. What is an imaginary number? Well, think about that. Well, let's do this one and I'll show you. Go ahead and figure out the discriminant here on this one. Again, you're doing b squared minus 4ac And you got a negative 3, right? So remember, what is the discriminant? It is the what of the square root? It's the radicand. So if you were going to do the quadratic equation, who cares what negative b is? Who cares what 2a is? The reality is right here, you're going to have square root of negative 3. Square root of a negative number is an imaginary number. Okay, it's imaginary. It's not part of the real number system. It's an imaginary number. You guys will get them in Algebra 2. We'll deal with them. But basically, they're square roots of negatives. And I've talked to you about this before. You can't come up with the value of a negative square root, because remember what a square root is. What number times itself 2 times equals the radicand? So even if I went to something you think might have an answer, like the square root of negative 9, positive 3 times positive 3 is positive 9, not negative 9, so the answer is not 3. Negative 3 times negative 3 is, again, positive 9. You can't take something times itself twice and get a negative, because positive times a positive is a positive, and a negative times a negative is a positive. So how do you end up negative? Well, the answer is you can't. It's an imaginary number. And we'll play with them in Algebra 2. So again, depending upon what way they want you to say, you're either going to say 2 complex number solutions, or you're going to say 2 imaginary number solutions. Just follow the directions, and the directions will lead you in which way they want you to go. But again, every imaginary number is a complex number. What is it? A negative radicand. We've been saying no solution on those, right? When you get into higher math, we'll come up with solutions to those. They'll be imaginary number solutions. Okay? It's okay. You know what? You can multiply an imaginary number times an imaginary number and get a real number answer. It's really cool. Yeah, it's awesome. Yes, of course. All right. Last thing here in this section, solving quadratics by the best method. All right, generally you put it in the general form. General form, again, is the same thing as standard form. Standard form, general form, same thing. Can you write standard form, general form? Go ahead and write it if you can. I'll write it in here while you guys fill it in. And again, we got to know that, because we know that that's where the a, b, and c come from for the quadratic equation, right? Ax squared plus bx plus c equals 0 is general form or standard form. Look, here's the order in which you want to decide which method to use. First thing you want to try is take the square root of both sides. So the first method you want to try is solving by roots, right? Which means take the square root of both sides. Anybody remember the condition that allows you to take the square root of both sides? What about general form has to be the case when we can take the square root of both sides? Abby?
You can't have a variable to the first power.
Exactly, right? That term has to be missing, right? The variable to the first power. If that's not there, we can take the square root of both sides. Now, let me just pause for a second and remind you, we did learn a method called completing the square, which can make anything into a situation where you can take the square root of both sides. But again, we're talking apart from that. All right, so that's generally the situation. Second, if that doesn't work, you're going to try factoring. Does everything factor? No. So when it doesn't factor, then you're finally going to use the quadratic equation. this is what they want to teach students. I will tell you this. I explained the other day why you should know all three methods. Because solving by factoring is a key method of solving third degree and above equations, which you're going to get. And you might as well learn how to do it on the easier second degree ones. Taking the square root of both sides is a means of solving any kind of squared equation that fits that category, and that's by far the most efficient method, so you should know that. The quadratic equation, however, will solve every quadratic. So if you're in the midst of taking, an SAT or an ACT, do you want to just use the quadratic equation? Perhaps. I can't remember if they provide you with the quadratic equation or not. Something wants to tell me they do. But again, for students, we try to get you to be as efficient as you can, so we try to get you to decide which method you're going to use. So I've got a couple examples here, and let's try to figure out which method we're going to use. So are we going to use roots? Are we going to use factoring? Or are we going to use the quadratic equation? All right, so there's your first example, and you make your decision. You have one of three choices: roots, factoring, quad equation. Roots, factoring, quad equation. You decide. All right, so hopefully you're going to move your 10, right? Going to add a positive 10 to both sides. Now you got it set equal to 0. And, oh, look at this. 3 positives and 5 negatives leaves me 2 negatives. I wouldn't have even actually, I shouldn't have moved that 10. Do we have an x to the first power term, yes or no? Not that I see. So we're going to solve this thing by roots. Let's just finish it off just for practice sake. Really, now we got to move that. We got to get everything on the other side, so this is going to be a negative 18. You guys remember how to solve it from here? So you got negative 2x squared equals negative 18. Can you finish it? Go ahead and finish it. You do it at your seat while I do it up here. Finish solving this thing. Finish solving it. Don't look up if you don't have to. You should be able to solve this from here. It's pretty simplistic. And I hope you didn't forget the plus minus, right? You didn't forget the plus minus, did you? I hope not. How many got it correct? Okay. Oh, by the way, biker analogy. Was there any guarantee me walking past them that they would do anything to me? No, they might not. They might say, hey, how you doing, man? Hope you have a great night, right? I mean, they might. They might. I walk by and say, hey, I've got an extra slice of pizza. You want one? All right, cool. I mean, they could have said, 50 nice things to me going by. Well, there's a possibility. It'd be bad news. So anyhow, such is life. All right, so that's the idea. Second one, it's already in standard general form. Can you solve the second one by roots? Yes or no? No. So what are you going to try next? Factoring. When your brain says factoring, what's the next thought your brain says? Factor out common factors first. I hope your brain always says that next. And why don't some brains say that next? Because you don't always have common factors. But your brain has to think it. Do we have common factors? No. But you got to think it. All right, 2x and x. I don't even know if it factors. It may not. Hey, at 13, all you have is 13 and 1. If I put the 13 here and the 1 there, I get 26 and 1. I know that's not going to work. I can try the 1 there and the 13 there. I have 2 and 13. Does that work? Guess how we're solving this one? Quad equation. But usually we try to factor first. And usually the factoring's not long and drawn out. We know whether we can or not. All right, for time's sake, we'll leave that one because you guys just did practice on the quad equation. C is unique. Just think for a second. How would you go about determining what to do with C, and how would you go about solving C? Think about it for a second, then I'll ask you. All right, who wants to give me a thought? Adam, what are you thinking? Yeah, you got to multiply this thing out because the parentheses are different. If they would have been the same, you could make it the parentheses squared and take the square root of both sides, right? But they're not. You got to multiply this thing out. So multiply it out and then decide which method you're going to use and go ahead and solve it. I'll do it here while you do it there. Definitely not going to solve it with roots, right? No common factors. Aha! Don't forget the last step is you set each of the factors equal to 0 and solve the little equation. Some of you tend to forget that in time. After a certain amount of time goes by and you haven't reviewed, you haven't looked at your notes, you haven't studied, you forget that the way you finish is set each parentheses equal to 0 and solve the little equation. And that's how you get the -1 to +6. All right, so a little bit of practice tonight, and we'll continue on. Test is coming next week. Can't remember if it's Wednesday or Thursday next week. Somewhere in there, okay?